Welcome back to the channel. If you're new here, please subscribe and like the video. If you have any suggestions or topics you'd like me to make a video on, feel free to comment below. I hope these videos are helping you. Let's get started. There is a silence in the night sky that has bothered me for as long as I can remember. You look up and see thousands of stars, and your intuition, that gut feeling that helps you navigate traffic or catch a ball, tells you that somewhere out there, someone must be looking back. It feels impossible that we are alone. But here is the problem with feelings. They evolved to help you survive on the African savanna, not to understand the structure of the cosmos. When you take that human intuition and apply it to the scale of the universe, it doesn't just fail, it snaps, it gets crushed. Because the moment you actually look at the math, the raw physics of how time, energy, and distance truly work, you are forced to confront a terrifying question. Why do we think our gut feeling has any authority over the laws of nature? On Earth, if you want to go somewhere, you go. If you want to go faster, you push harder. But out there, the rules change. The universe has established 5 merciless barriers, 5 absolute walls that prevent civilizations from ever meeting. And I'm going to be honest with you. These aren't just obstacles, they are dead ends. By the time we finish, you might feel smaller than you ever have before, but you will also understand exactly why no one has come to save us, and why no one ever will. Let's strip away science fiction, forget Hollywood fantasies. Let's look at the universe as it actually is. The first barrier, the one that shatters our minds before we even leave the ground, is distance. We say the word space casually, but we don't truly grasp what it means. We are biologically incapable of comprehending the numbers involved. Your brain is designed to understand distances you can walk or drive. Maybe if you travel often, you can conceptualize a flight from London to Sydney. That's about your limit. So let's push beyond it. Start with Earth. It's a rock about 12,742 kilometers across. To you, that's an entire world. To the universe, it's dust. You can fly around it in less than 2 days. It feels manageable. Now step back. The sun is about 150 million kilometers away. Light, the fastest messenger in existence, takes more than 8 minutes to cross that gap. If the sun vanished right now, you'd still enjoy sunlight for 8 minutes before darkness arrived. That distance can still be measured in time in a way your mind can barely handle. Now take the next step. The nearest star, not a distant galaxy, just our next-door neighbor, Proxima Centauri, is 4.24 light years away. Your intuition hears 4.24 and thinks that sounds small, but translate it into human terms. The fastest object humanity has ever built, the Parker Solar Probe, travels roughly 692,000 kilometers per hour. That's fast enough to go from New York to Tokyo in under a minute. It's astonishingly fast. If you boarded that probe and aimed for Proxima Centauri, how long would it take? A month? A year? No. It would take about 6,600 years. If you had left Earth when the Great Pyramids were completed, traveling at the fastest speed we have ever achieved, you would only just now be arriving. And that's our closest stellar neighbor. Scale up again. The Milky Way galaxy, our home, is about 100,000 light years across. Crossing it at the speed of the Parker Solar Probe would take hundreds of millions of years, longer than the entire evolutionary history of mammals. You would evolve into something entirely different before reaching the other side. We've established that space is vast, but maybe you're thinking, so what? We just need to go faster. That brings us to the second barrier, the speed of light. Most people think of the speed of light, about 300,000 kilometers per second, as a technical hurdle, like the sound barrier once was. We thought we couldn't fly faster than sound. Then we built better engines and did it. So surely we just need a better engine to break the light barrier. Right? Wrong. The speed of light is not an engineering limitation. It is built into the structure of reality. It is the speed of causality, the maximum speed at which one event can influence another. In everyday life, if you push a car, it accelerates. Push harder, it accelerates more. That's linear thinking. But as you approach the speed of light, physics stops being linear and becomes asymptotic. As you pump energy into an object, it gains kinetic energy. But near light speed, that energy stops making it go faster and instead increases its relativistic mass. The harder you push, the more the universe resists. To accelerate any object with mass to 100% of the speed of light requires infinite energy. Not a lot of energy. Infinite energy. There isn't enough energy in the entire observable universe to accelerate a grain of sand to light speed. It's a vertical wall. You might reach 90%, maybe 99%, even 99.9999% if you burn unimaginable amounts of fuel, but you will never cross it. So when people ask why aliens don't just come here faster, the answer is simple. They can't. No matter how advanced they are, they live in the same universe and obey the same physics. Suppose we accept that limit and decide to travel at 10% of the speed of light. Slow on a cosmic scale, but blisteringly fast for us. Now we encounter the third barrier, energy, and the brutal reality of the rocket equation. In 1903, Konstantin Tsiolkovsky wrote down the rocket equation. It sounds dry, but it is merciless. To move a ship, you need fuel, but fuel has mass. To move that fuel, you need more fuel. That extra fuel also has mass, requiring even more fuel. It's an exponential trap. Imagine sending a ship to the nearest star within a human lifetime, say 40 years. You must accelerate to a significant fraction of light speed. Then you must decelerate when you arrive. That means carrying all the fuel needed for braking across the entire journey, accelerating that mass the whole time. Using our best chemical rockets, the fuel required to send a single human to Proxima Centauri in a reasonable time frame would exceed the mass of the observable universe. Upgrade to nuclear fusion, even though we don't yet have practical fusion rockets. Even then, the ship would need to be almost entirely fuel. Think of a flying fuel tank the size of the Empire State Building delivering a payload the size of a toaster. What about antimatter, the most potent hell imaginable? 1 gram could level a city, but we produce antimatter atom by atom in particle accelerators. It costs billions of dollars to create mere nanograms. To fuel a starship, you would need to dedicate the entire energy output of humanity for millions of years just to fill the tank once. And the universe operates on cost-benefit logic. Even if a civilization could harness the energy of a star, a Dyson sphere-level society, they would also be advanced enough to calculate efficiency. They would see the energy cost of sending a biological being or robot to a tiny planet thousands of light years away and realize it's wasteful. Why expend a star's energy visiting a possibly unremarkable world when you could use that energy to build a digital paradise at home? Advanced civilizations are not only powerful, they are efficient. Interstellar travel is profoundly inefficient, but suppose they ignore efficiency and launch anyway. Then comes the fourth barrier, biology. We imagine humans in sleek suits exploring space, but the human body is fragile. It evolved for one environment, Earth. 1 g of gravity, atmospheric pressure, magnetic shielding. Space is a radioactive nightmare. Outside Earth's magnetic field, you are bombarded by cosmic rays, high-speed protons and heavy ions moving near light speed. They don't just hit your skin. They penetrate hulls and tear through your DNA, shredding it like a shotgun blast through a library. Even a trip to Mars significantly increases cancer risk. A journey to another star would expose you to lethal radiation long before you left the outer solar system. To survive, you'd need shielding meters thick, lead, water, concrete. But shielding up DDS mass. More mass means more fuel. More fuel means more mass. The loop returns. Then there's gravity. In zero gravity, bones lose density. Muscles atrophy, the heart weakens, eyes deform. Astronauts returning from 6 months on the International Space Station come back physiologically altered. Imagine a journey lasting centuries. Some suggest cryosleep. But freezing living cells forms ice crystals that puncture membranes, destroying tissue. We do not know how to freeze a human without causing catastrophic damage. What about generation ships? Let people live and die aboard, with descendants eventually reaching the destination. But place 500 people in a closed metal habitat for 500 years and social systems fracture. Language evolves. Genetic diversity shrinks, increasing defects. By arrival, they may not even remember their original mission, let alone be capable of meaningful contact. Biology evolved for Earth. It does not run well on the hardware of deep space. Perhaps aliens are not biological, but artificial. Machines, silicon-based intelligences. Silicon doesn't get cancer, true. But silicon is vulnerable to radiation too. High-energy particles flip bits in computer memory, corrupting data and damaging electronics. Over interstellar timescales, even machines degrade under constant cosmic bombardment. Finally, there is time itself and our radio footprint. Human civilization has been broadcasting radio signals for just over a century. That means our radio bubble extends only about 100 light years in every direction. A tiny sphere in a galaxy 100,000 light years across. Even if a civilization 1,000 light years away detected our earliest signals immediately and responded at light speed, we would wait 2,000 years for a reply. Most of the galaxy doesn't even know we exist. And if civilizations rise and fall over thousands or millions of years, the odds of two overlapping in time and being close enough to communicate are vanishingly small. So when you look up at the night sky and feel that someone must be looking back, remember, feelings are not physics. Distance is overwhelming. Light speed is an absolute wall. Energy requirements are exponential. Biology is fragile. And time isolates us in vast cosmic silence. The universe is not hostile. It is indifferent. And in that indifference lies the answer to the silence. Over thousands of years in deep space, without any repair shop waiting at the destination, entropy takes control. Circuits slowly degrade. Metal structures fatigue. Micrometeoroids no larger than dust grains strike the hull with the explosive force of hand grenades because of their immense relative velocity. Even machines have lifespans, and the galaxy stretches far beyond any warranty ever written. Now we arrive at the fifth and final barrier, the one that truly explains the silence, information, and time. Suppose a civilization somehow overcomes distance, energy, and biology. Suppose they exist. Why haven't they called? Because the universe is a terrible communication network. Humanity has been broadcasting radio signals for only about a century. That means our presence has formed a bubble around Earth roughly 100 light years in radius. In a galaxy 100,000 light years across, that bubble is microscopic. We are whispering into a hurricane. For someone to hear us, they must be observing our tiny region of space at precisely the right moment and on exactly the right frequency. Consider the scale of the cosmic haystack. Billions of stars, billions of possible frequencies. If an alien civilization pointed a radio telescope at Earth in the year 1500, they would detect nothing. We had not yet invented radio. If they listen today but are 200 light years away, they still hear silence because our earliest signals have not reached them. This creates the problem of asynchronous civilizations. Societies rise and fall. Humanity has been technologically capable for perhaps 2 centuries. We might survive another 1,000 years, maybe 10,000 if we are fortunate. But the universe is 13.8 billion years old. The probability that 2 civilizations exist at the same time, in the same region of space, and at comparable technological stages is vanishingly small. It is like 2 fireflies blinking once in a vast forest. One flashes on Tuesday, the other on Friday. They never see each other. Perhaps a civilization once thrived near Proxima Centauri 1 billion years ago. They are gone. Perhaps one will emerge there 1 billion years from now. By then, we will be gone. The tragedy of the universe is not necessarily that it is empty, but that its inhabitants arrive at different times. Combine these 5 barriers: distance that overwhelms the mind, a speed limit embedded in reality, energy requirements that escalate exponentially, biology that fails in deep space, and time that disrupts communication. And the conclusion becomes stark. Aliens are not on their way. That brings up the inevitable question, what about UFOs? What about the Navy videos? Mystery is fascinating, but physics remains indifferent to fascinate. Ion. We see footage of objects apparently accelerating from 0 to extreme speeds almost instantly. Consider what that implies. The g-forces required would be enormous, thousands of times Earth's gravity. Under such forces, electronics would be crushed, metal structures would fail, and any biological pilot would be destroyed instantly. An object moving through the atmosphere at such velocities would also violently interact with air molecules, generating intense heating and plasma trails bright enough to illuminate the sky. Yet the videos show none of this, only indistinct shapes. Which is more plausible, that a distant civilization mastered energy on unimaginable scales, circumvented inertia, nullified aerodynamic shock waves, traveled thousands of light years, and then revealed itself through ambiguous infrared footage? Or that the observations involve camera artifacts, optical effects, sensor glitches, drones, birds, or misinterpretations? Extraordinary claims require extraordinary evidence. Blurry footage is not extraordinary evidence. If a civilization had truly arrived with the energy required for interstellar travel, their presence would be unmistakable at a physical level. But this is not a bleak ending. When we let go of the fantasy that someone is coming to rescue us or conquer us, we are left with something deeper. We are forced to see the universe as it truly is, structured, lawful, consistent. The same constraints that prevent faster than light travel also preserve causality. If light speed were not a limit, causes and effects could unravel. The stability that confines us is the same stability that allows stars to shine steadily, atoms to remain intact, and life to evolve over billions of years. The silence compels maturity. No one is coming to repair our climate, resolve our conflicts, or manage our future. This fragile blue planet is the only lifeboat we have, and there is a profound beauty in that isolation. If the cosmos were crowded with starships, Earth would be ordinary. In a silent universe, Earth is extraordinary. Life is a rare statistical event that occurred against staggering odds. We are the universe becoming conscious of itself, and we have not stopped searching. We have refined the search. We look for technosignatures, for the waste heat of massive energy harvesting structures, for coherent laser pulses, for subtle anomalies in starlight. We listen not with desperation, but with patience. We may never meet another civilization face to face, but we share the same physics. The carbon in your body and the carbon in any distant organism were forged in ancient stars. We are connected through the fundamental laws of nature. So when you look up at the night sky and feel that immense silence, do not feel small in a negative sense. Feel significant. We are here. We are capable of understanding. We are the improbable outcome of 3.8 billion years of cosmic evolution. The barriers, distance, time, energy are real. But ignorance is optional. Keep looking upward. Keep asking difficult questions. The universe does not owe us answers, and that is precisely what makes discovering them meaningful.